Today we're going to be teaching you everything you need to know about vectors, adding vectors, Pythagorean theorem, resolving vectors into components, and how to interpret them. A vector has a magnitude and it has direction, okay? What does that mean? A magnitude is your value, okay? So let's say I'm talking about speed. Speed, the value of my speed might be 40 miles per hour. So I said a vector has magnitude and direction. The magnitude is 40 miles an hour, the direction is northbound. When we deal with vectors, vectors are expressed as an arrow, okay? So let's say my car is going 40 miles per hour northbound on the parkway, okay? So that vector would be drawn like this. The arrow points northbound, it points up, and when you're drawing more than one vector, you need to keep in mind that the length of the arrow should increase as the magnitude increases, okay? So if I were drawing one car going 40 miles per hour northbound and one car going 20 miles per hour northbound, this 20 miles per hour vector should be about half the height as the 40 miles per hour vector. Now that we understand that arrows represent vectors, let's talk about the tip-to-tail method for vector addition. If I have a displacement vector, let's say I'm talking about displacement. If you don't know what displacement means, it is your change in position, okay? If I start on this side of my whiteboard and I walk over here, my displacement has been about 1 meter to your right. This has been 1 meter this way, okay? That is my displacement vector. My position changed by 1 meter, the magnitude is 1 meter, and the direction is to your right. When we're adding vectors, we need to add them tip to tail. If I were to walk towards the camera by half a meter, then I were to walk to your right by 1 meter, then I were to walk back to my whiteboard by half a meter, I could draw that on my whiteboard. I say I walked towards the camera by half a meter. I walked to your right by 1 meter. Notice this arrow is double this arrow. And I walked back upwards half a meter, okay? If I add them tip to tail, then the resultant vector that explains the entire motion is, let me use a different color for this, is this vector. This right here is my net displacement vector, and it is 1 meter. My net change in position, my net vector, is 1 meter to the right. Let's talk about resolving vectors into components. So let's say I have my x-axis here, I got my y-axis here, and let's say I have a cannon. And my cannon launches a cannonball upward like this. This is the cannonball's velocity vector, okay? I need to resolve this vector into components. That means I need to have a component, a vector in the x direction, and I need to have a vector in the y direction, such that if I add those two vectors together, I'm going to get my original vector back. So how do we resolve a vector into components? Well, we need two things. One, we need the original vector, obviously. Two, we need its angle, the angle that the vector makes with one of my axes, okay? So in this case, I gave the angle with respect to the x-axis. If you want the angle with respect to the y-axis, well, the x and y-axis are at 90 degrees. So if you want this angle, I'm going to call this phi. Phi equals 90 minus theta. So what I'm going to do is I'm going to draw an imaginary line here, and I'm going to notice that now I have a right triangle with my imaginary line. That means I'm going to use trigonometry. Remember that sine theta equals opposite over hypotenuse. So if I want to find the length of my opposite side, I got to multiply it by my hypotenuse. In this case, I'm given my hypotenuse. It's my velocity vector. So my velocity vector times sine of theta is going to equal my velocity vector, the component of my velocity vector in the y direction. Likewise, my velocity vector times cosine theta, because cosine theta equals adjacent over hypotenuse, where this is my adjacent side, is going to equal the velocity component in the x direction, okay? So This is the component of my velocity in the x direction. This is my component of the velocity in my y direction. And if I were to add them tip to tail, as I've drawn right here for you, my resulting vector would be originally the y, as you can see. If I superimpose this on here, the resultant from adding these two vectors together is my original velocity vector. And so now let's continue this example with real numbers. Let's say I have a cannon that is going to shoot a cannonball out of its barrel at 40 meters per second, okay? And this cannon makes an angle of 25 degrees with the x-axis. We're going to want to resolve this into components, okay? So I'm going to draw my imaginary right triangle. Got my right angle here. And let's say I want to start with the y component of my velocity. Let's call this big V sub y. Big V sub y is my opposite from my angle, so it's going to be 40 meters per second multiplied by sine of 25 degrees. The velocity in my x direction is going to be my 40 meters per second times my cosine of 25 degrees, because cosine deals with the adjacent. And these, if I were to get my calculator out, make sure your calculator is in degree mode, not radian mode, because we're going to be dealing with both types if you're taking this for a physics class. So this velocity in the y direction is going to be 16.9 meters per second. And the velocity in the x direction, we're going to multiply it by cosine of 25 degrees, that's going to give me 36.3 meters per second. Okay? And if you notice, if I add 16 to 36, that's more than 40. Well, that brings us to the next topic, which is how do we add vectors numerically? I told you about the tip-to-tail method. The tip-to-tail method only tells us how to add vectors to get the resultant direction. Now we need to know how to add vectors to get the resultant magnitude, the resultant value of the vector. Well, we're still going to draw the triangle like this, but we're just going to use Pythagorean theorem. If I have my x vector right here, which as we said was 36.3, and I have my y vector right here, which is 16.9, this should be longer. And if I draw the resultant vector as the hypotenuse, I can use Pythagorean theorem, where this is c, this is a, this is b, where a squared plus b squared equals c squared. A squared is going to be 285.8. B squared is going to be 14.2. And now I'm going to add these two together and take the square root of it. And I'm going to get exactly 40 back as my c. And you see my original vector was 40 meters per second. That is how we deal with vectors, guys. Good luck studying for your tests. Leave a like if you think it deserves it. If you need extra help, go to meekextrahelp.com, or you can go join the Discord server. Anyway, have a fantastic day and enjoy life.